Я хочу пройтись немножко по истории, как делается программное обеспечение. Потому что сейчас вопрос App Security стоит действительно очень остро. И App Security — это сейчас что-то есть новый фронтир, на котором большинство проблем с уязвимостью информации как раз происходит. Я бы сказал, грубо говоря, что фактически в большинстве самых таких знаменитых data breaches, которые стали знамениты на весь мир, в большинстве случаев какое-то программное обеспечение кого-то допустило. И что самое интересное, что в принципе сфера computer security, она не новая. Но в то же самое время, если вы когда-то встретитесь с security professional, у которого действительно какой-то стаж работы, скорее всего, у них опыт к программированию будет очень-очень ограниченный. Просто для ориентации. Можно просто поднять руки, у кого есть хорошие навыки к программированию. Кто считает себя неплохим программистом? Несколько человек. В принципе, так оно и есть. Большинство людей, которые занимаются security, к программированию, имеют довольно косвенное отношение, и сейчас это как раз то, что должно меняться. Поэтому я быстро поговорю про эволюцию программированных языков, и самое главное, это что это для нас должно значить. Также методика, по которой разрабатываются программы, тоже уже, в принципе, изменилась. И нам тоже нужно знать, во-первых, как это меняется, зачем, и что для нас это должно значить, как для security professionals. Изначально давайте поговорим про, что такое язык программирования и сколько их нужно. It's truly staggering how many programming languages there are today. If you think about it, can you guess how many programming languages there are? Many. Any guesses? Throw out a number, quick. 100, all right? 200. Anyone goes higher than 200? 350, I like that answer. We'll get back to that. So, why are there so many programming languages? Well, I can answer that question by asking you another question. See, that's what consultants do. We ask you a question and then we ask you another question. What is your favorite text editor? What are the chances that in this room we're going to find 3 people that agree on one text editor that they all like? How many text editors do you think there are? Let's ask that. That's a simpler question. A text editor, simple program, little tiny thing, edits text, easy, right? How many text editors are there? Thousands? Well, thank God, no. There's actually about 120. There's about 120 text editors. Now, this is a program that takes a plain text file and lets you change things, and there's 120 of them. A programming language is far more complicated, right? So in reality, there is actually over 730 programming languages that have at some point been developed, coded against, documented, and put into production. And this chart here is actually not a joke. This chart is an actual representation of the evolution of programming languages. Everything, of course, started with the assembly on top and skated all the way down to the programming languages we love and hate today. So with 730 programming languages, obviously they're all going to be not that different, but some differences. The one that you really want to focus on is the difference between interpreted and compiled programming languages. Now, there is not a lot of programmers in the room. If there is a Java programmer, I promise you, I know Java is a hybrid, it fits into both categories, but for the purpose of our conversation, let's talk about compiled and interpreted. Compiled programming languages are the older generation. That's your languages like C, C++, languages that typically need to be compiled before they do something. Interpreted languages are languages like Python, like Ruby, languages where you construct a statement and it can already run. It has some dependencies. Now, compiled languages are hard to learn. Well, you basically have to really know what you're doing before that program even runs or does anything. Interpreted, very easy to learn. Google is responsible for probably half the programmers today. Compiled languages therefore require training. And through that training, someone will teach you right from wrong. Interpreted languages, a lot of people are self-taught. You don't have to go to training. You don't have to really do a lot of studying. You can just start Googling for answers and get there. Compiled languages are faster. I mean, that's kind of where we started. They compile into closer to a machine language, while interpreted are inherently slower. But we solved that problem, right? All you do is you just put more systems in line, and all of a sudden, you don't have to optimize anything. You don't have to get efficient. You can just build more systems. Amazon loves that. Compiled programs are still, there's a concept of a standalone application. By the looks of things, there's probably only very few people in this room who remember what it's like to download one program and have it run without anything else. it's a rare privilege. Nowadays, if you're downloading a program, the chances are you have to download 6 other programs that will somehow make it work. And of course, compiled languages had dependencies, but they were for the most part commercial. They were commercially supported. There was some assurance of quality. While today, interpreted languages are for the most part all open source dependencies. Now, when you think open source, if you're thinking a group of highly expert engineers working together to craft a beautiful program, that is not what happens. What happens is there's usually one person who does something, pushes it out into the cloud, and doesn't look at it again for 6 months. So quality varies. How many modules do we really need? So this is a very interesting chart. For those of you who are really trying to get into the application security space, I recommend getting to know the modulecounts.com website. This site tracks all the modules in the most common repositories. So here's something to pay attention to. Perl, one of the oldest scriptable languages we've got. It was first released in 1987. It has less than 40,000 modules in the library. Now, 40,000 seems like a large number, but until you look below. So since 1987, there's only 40,000 modules that have been published. Now, look on the other spectrum at NPM or Node.js. It's almost frightening to believe that that language did not exist. That platform didn't exist until 2009. And today, there are over 700,000 modules currently published in that repository, and they are growing at a rate of about 540 per day. So every single day, on average, there's 540 new modules being pushed out. For security, what does that mean? Well, hackers have already figured out how to create fake modules, modules that look just like the real ones. Same techniques that they use for phishing to trick you to go to a website by switching letters around or playing on your dyslexia and tricking you into going to a fraudulent website. They're now using that same technique to lead you to a fraudulent module. There have already been documented cases in several banks where their developers were targeted by malicious hackers through developer community, through the community boards, trying to advertise modules that had backdoors built in. So when you're thinking from the security standpoint, you've got 714,000 NPM modules of which you don't know who wrote them or what kind of quality there is. So this is the evolution of programming that you want to think about when it comes to security. Of course, computing infrastructure doesn't do us any favors either, because now we have virtualization running on top of virtualization running on top of virtualization. The same way that systems people don't make good programmers, infrastructure as code hasn't given us any favors, because at the same point, developers don't really know much about systems or how to harden them or how to configure them well. So all of that has to somehow come together. The way we write software has changed as well. Now, there was a time, and I remember it fondly, and if there's anyone close to my age in this room, you will as well, this is what software development was. You spend some time writing requirements, you gradually go to analysis design, someone writes the application, and then things stop. And then comes in the security person who sits around for a month, tests the application, tests the code, signs everything off, and off we go into production. This used to take about 6 months. This is what a development cycle was. It's called waterfall. So about 6 months later, finally, you're in production. The problem with that approach is that once you're in production, if somebody finds a problem, well, it'll probably take you 6 months before that problem is fixed. Of course, nobody liked that. So we came up with something called Agile. It just sounds great. Agile, let's get things a little bit faster. So now we're going from idea to design to code to test in much, much faster increments. We're still deploying pretty infrequently. We're still deploying once in a while, but at least we can have more frequent conversations about features. Things are happening faster. Sometimes things even get documented. But even that wasn't fast enough. So what do? Not only do we create a continuous cycle of development where you're going from design to an idea to code to production pretty much on an ongoing basis, but just to give security people a heart attack, we put the word cloud in the center, just to test your reflexes. And we're supposed to be okay with this. Like, oh, no big deal, that's fine. Take our application, take our data, shove it into the cloud, change it every single day. Yeah, that's fine. I don't see any problems with that. So this is the evolution that we have to contend with. Now, what does it actually mean? Well, you have to first up your own knowledge of software development so that you know how to take advantage of these tools and how to take advantage of these new methodologies. For example, these three methodologies are actually not that dissimilar, because in all cases, you're still designing an application, you're still building it. At some point, you're still going to do some kind of testing. The biggest difference is that with DevOps, you're deploying constantly. You're deploying nonstop. That's the key difference here. And so you can cater to that. You can actually discuss this with developers and say, look, I'm going to let you run your cloud-driven cycle, but in return, I'd like my bug fixes to be out there just as quickly. So there's a way for you to actually harness this power and leverage it. Now, what does it ultimately mean? Well, that means that in addition to increasing your own intelligence about software development, you have to also research what tools and frameworks exist to help you along the way. Now, apart from being a CTO of a startup called Tronics, I've been a volunteer for an organization called OWASP for several years. Has anyone here heard of OWASP before? Okay, I love that. So OWASP is a wonderful organization, as I'm sure you already know. Here's the one you'll love. Everything on there is free. And one of the things that's free on there is software assurance and maturity model. I have been a volunteer on this project for over 5 years, and we're currently in the process of releasing the next version of this maturity model. This maturity model will actually walk you through, in terms of DevOps, the complete life cycle, starting all the way from a policy, design, and idea, all the way through into the implementation. My recommendation for all of you is please take a moment and investigate what security means in this new world. Take a look at the software assurance and maturity model and try to understand what it can do for you. Because one of the things that's absolutely unquestionable is that verification is what security means for applications in 90% of the time today. People don't talk about security until the application is out. And then they say, well, let's test it. And then they find a bunch of bugs, and then they take these bugs and give it back to developers, and that's basically what security means. But the role of security has to change, because you have to take advantage of these new technologies. You have to take advantage of these new methodologies. You need to actually have conversations about security at every stage within the development lifecycle. You can't just hire a pen tester. You actually have to talk about design. You have to talk about requirements. You have to make sure that defects don't end up in production by design, not because you found something and you made a developer fix it. Also, another thing that's very important, and this will help you sell this idea within your organizations, if you can eliminate a problem at the governance section, in other words, if you can write a policy that says you can't do something, and you can consider that a cost factor of 1, that same problem, if it's discovered once the application is in production, will cost 30 times more to fix. So what it means is that you can actually argue for a reasonable return on investment when it comes to improving your application security, as long as you don't do it just by finding more bugs, but you do it by partnering with developers and actually forming better relationships with them and investing more in secure software design. For those of you that want to learn more about OWASP SAM, I strongly recommend going to owaspsam.org. This is the website where we're publishing our work in progress in real time. Now, we're calling this the Devops Release, and we call it that for 2 reasons. Number 1, this is the release where we're taking the model and we're actually adapting it to DevOps. The second reason we're calling that is because the process of creating this model is actually done using DevOps techniques. We have a continuous integration, continuous deployment pipeline. When we provide content into this model, it shows up on this website within a minute. So we're actually leveraging DevOps techniques to make sure that this gets built quickly and this gets built well. The entire OWASP SAM model is in Markdown language, hosted on GitHub. I recommend all of you, if you do take a look at it and you have some suggestions, please submit the issues. The entire model is open source, common license. You can use it in any way you like. For those of you with a stronger interest, I know these sessions are not meant to have questions, but I'm going to certainly hang around. Please find me, ask me about OWASP, app security, how this whole world turns around. I'll be more than happy to share that information with you. In summary, security role needs to change with applications. The way we used to secure servers and firewalls has changed. you just can't plug holes anymore. You have to think about the design. The costs are different. You need to make sure that you increase your own IQ about software development. Now, personally, I'm probably the world's worst developer, but I know how to do it, and I had to learn in order for me to be effective at what I do. And this is really what you need to get to, is you need to be more effective in your job by understanding the issues of software development. And definitely invest in learning about maturity of software development processes, because it is that maturity that's going to really help you along and really help you implement some of the changes that I'm sure you're looking for. So with that, I'd like to thank you all for putting up with me. Я останусь после этой презентации здесь. Пожалуйста, если есть какие-то вопросы, обращайтесь. Благодарю за внимание.